And back to the message. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, so eventually today we're going to go ahead and wrap up section 5.8. We're going to look at the second half of it. This homework assignment tonight is to finish up section 5.8 as well as doing the chapter review. I just want to give you a heads up. So tomorrow, Friday, we'll review for the test. Monday will be the test. Monday, there will be no class meeting, no Zoom meeting. You'll just take your test. Also, I will not be available this weekend. So if you send me messages during the weekend that require me to do something in WebAssign, I won't be able to respond. I tried this morning to get into it on my phone and didn't have much luck. Anyway, so just be sure to get everything done, all your questions answered by office hour tomorrow afternoon. Okay, having said that, we're going to look at a question from, oops, hang on here, 5.8 part 1. This is number 11. Okay, and I'll show it here on the screen. So it says divide the polynomial by the monomial, simplify your answer completely, number 11. So we've got negative 6x squared y cubed plus 9xy squared minus 3xy, that whole thing divided by negative 3x squared y squared. All right, so we've got a polynomial divided by a monomial. So we're going to take each term in the numerator and divide it by the term in the denominator. Let's see, this is going to be plus 9xy squared over negative 3x squared y squared minus 3xy over negative 3x squared y squared. So now we've got 3 separate fractions and we're going to reduce each one independently of the others. Okay. Negative 6 over negative 3 reduces down to 2 over 1. Hang on a second here. Okay, sorry. I was looking at the answer and they've got it written in a different order. I'm going, something was wrong, but we're fine, we're fine. Sorry about that. Okay, x squared divided by x squared is like 1 over 1. And y cubed over y squared would be y to the 1 power. So on top I've got 2 times 1 times y, and on the bottom I've got 1. So the whole thing would just be 2y, okay? And plus, next term, 9 divided by negative 3 would be negative 3 over 1. X over x squared would be x to the 1 minus 2, or x to the negative 1 power. Y squared over y squared would be y to the 0 power, which is 1, or just 1 over 1. So now I've got negative 3 x to the negative 1. But that would be negative 3 over x to the positive 1. Okay? And in fact, I'm going to take this and just write minus 3 over x. Are you okay how I got from there to down here? Any questions there? I could have written plus a negative, but just seems cleaner to write minus 3 over x. Okay, next we've got minus 3 over negative 3 is negative 1 over 1. X over x squared would be x to the negative 1. Y over y squared would be y to the negative 1. And this is all over 1. So I've got subtracting negative, which would be like adding a positive. But I'm going to take x to the negative 1 and put it on the bottom and make it x to the positive 1, y to the negative 1 on top and make it y to the positive 1 on the bottom. So then I get plus 1 over xy. So there's my final answer, 2y minus 3 over x plus 1 over xy. Any parts of that you want me to go over again? Okay with that?
Can we do another one?
Sure, sure. Do you have a specific one you want to look at?
One similar to that one?
Right,
I don't know. I'm a little late to your Zoom.
I see. Okay. I'll tell you what, let me pull one out of the book here. And we've got.
Is this a review for the test on Monday?
No, this is answering questions from last night's homework.
Oh, okay.
So do you still want me to do one or?
No, I'm fine.
Okay, all righty. We shall go onward unless anybody else has any questions from yesterday. All right, so let me get back to the whiteboard screen and I'll get rid of that. Okay, so now we're going to be taking a look at part 2 of section 5.8. So here's what I want you to do. I assume that you all have paper and pencil in front of you. I want you to write down in front of you the number 407. Okay, I just want you to do that. Write it down. Okay, is everybody done?
I'm done.
Yes.
Okay, good. All right. Did any of you write this?
No,
Why not?
because it's
That's
7.
407.
I wrote 400 or 407.
Why did you put a 0 there?
I don't know. I just
You just did it, huh?
when you just say 407, I just assume it's like 407.
But why is the 0 there?
Because there's no tenths value.
Oh, so what does that 0 represent?
Nothing. 0.
Well,
100th value,
what's that?
100th value.
No, the 4's in the 100th value.
That was the 10th value, but there's no 10th.
So it's a placeholder for the tens.
Right.
So basically this is saying we've got 4 hundreds, no 10s, and 7 1s.
Correct.
But I just said 407. So why put the 0? I didn't say anything about 10s. Why do you need that 0 there? What if I didn't put it there? What if I just wrote that?
Then it's just 47.
It looks like 47, doesn't it? So we really need, even though I didn't say we have 400s, no 10s, and 7 1s, we need that 0 so that we know where each number is, what its placeholder value is, right? So placeholder values, even if they're 0, are important to make things be in their right place, right? Okay, all right. Now, what does that have to do with anything? Well, we're going to see. Let's take the following problem, which is a squared minus 25 divided by a plus 5. Okay, I'm going to write this in the long division form. So I'm going to have a plus 5 on the outside and a squared minus 25 on the inside, right? Inside, outside, they're both in descending powers of the variables, so we should be good to go. We okay?
Yes.
All right. So the next step, we take the leading term inside divided by the leading term outside. So we take a squared divided by a, which is a to the first power. Let's see, we'll just put it up here somewhere, a, okay. Then we take that times what's outside, distribute, I get a squared plus 5a, and I write that up here, okay. Then I'm going to subtract that from what's up above and change it to addition of the opposite. A squared plus negative a squared is 0. There's a problem. What's the problem here? What's going on? There's a mess.
We can't subtract 25 from 5a
Or the other way around either. Why not?
because the 25, the negative 25 doesn't have a variable a or the exponent of a.
Yeah, so they're not like terms, are they? They have different placeholders. So let's go back and let's do this problem again. Actually, we never actually finished it. What we're going to do now is we're going to put in a placeholder. So I've got a plus 5 on the outside, a squared plus 0a minus 25. So I'm creating a column for the a to the first power. Okay, I didn't change the value of the original a squared minus 25, but I created a column, if you will, to put the a to the first powers in there. Okay, so let's see if it works out now. Leading term divided by leading term, a squared divided by a is a. That's going to go right up there. Okay. Then I'm going to take a times a plus 5, which is a squared plus 5a. Going to subtract it from what's up above, change it to addition of the opposite. Now things are going to work out nicely. A squared plus negative a squared is 0a squared. 0a plus negative 5a is negative 5a. Okay, see how that worked out?
Yes.
Bring down the next term. Start the whole process over. Leading term inside divided by leading term outside. Negative 5a divided by a is negative 5, so minus 5 goes up there. Minus 5 times a plus 5, negative 5a plus 25. No, minus 25, my bad, sorry. Minus 5a minus 25. Subtract that quantity from what's up above, change it to addition of the opposite, and we get 0 remainder. Which means that a squared minus 25 divided by a plus 5 equals a minus 5. Let's see if that's true. A plus 5 times a minus 5 is going to be what? A squared minus 5a plus 5a minus 25. And it works. Okay, so what do we do there? We put in missing powers of that polynomial inside. Okay. All right, let's take a look at another example. Let's see here. 25x to the second power minus 16 divided by 5x minus 4. So outside, I'm going to have 5x minus 4. Inside, I'm going to have 25x squared plus 0x minus 16. Now, I think somebody asked once, does it have to be plus 0x? Could it be minus 0x? It doesn't matter because it's still 0. Okay. In other words, this term, it's 0. So whether you put plus or minus in front of it, it's not going to matter. It's still 0. Okay. So now, let's see here. We're going to take the leading term inside divided by the leading term outside. 25x squared divided by 5x equals 5x. Okay. Then we're going to take 5x times 5x minus 4. Distributing, we get 25x squared minus 20x. So 25x squared minus 20x. Again, if I'm going too fast, let me know. I can slow down. So then we're going to subtract that quantity from what's up above, change it to addition of the opposite. We get 0x squared, 20x minus 16. 20x divided by 5x is 4, so plus 4. 4 times 5x minus 4 is 20x minus 16. Subtract that quantity from what's up above, change it to addition of the opposite, and again, it comes out exact with no remainder. That doesn't always happen. It's just that these particular problems have no remainder. Okay. Let's see here. Here is another one. X cubed minus 8 divided by x minus 2. So outside I've got x minus 2, but inside I've got x cubed plus 0x squared plus 0x to the first power minus 8. So I had two terms missing there. That's like writing 4006. You'd write 4006. So I had to have two placeholders that I filled in there. Okay. All right. So now leading term divided by leading term, x cubed divided by x is x squared. X squared times x minus 2, distributing x cubed minus 2x squared, x cubed minus 2x squared. We're going to subtract that quantity from what's up above. We'll change it to addition of the opposite. X cubed plus negative x cubed is no x cubed at all. 0x squared plus 2x squared is 2x squared. And I'll bring down the next term, which is 0x. We're going to start all over. Inside divided by outside leading term. 2x squared divided by x is 2x, so plus 2x. 2x times x minus 2, 2x squared minus 4x, 2x squared minus 4x. We'll subtract that quantity from what's up above. Change it to addition of the opposite. Add up the columns. 2x squared plus negative 2x squared is 0x squared. 0x plus 4x is 4x. Bring down the next term, the minus 8. Start the process all over again. Inside divided by outside. So 4x divided by x is plus 4. 4 times x minus 2 is 4x minus 8, which we put over here, and we subtract. Change it to addition of the opposite, and we get 0 remainder. So all of this equals that.
I have a question.
You betcha.
The last question that we did, okay. No, for some reason, I thought you put a 9 on top, and I was like, why is it a 9, but it's a 4?
Right here.
Yeah.
Yeah, that's
Okay.
my sloppy writing.
I was a little confused, like, why did I get a 9? I was like, what?
Okay, let's see. There we go. How's that? Is that better?
Thanks.
You're welcome. You're welcome. Okay. Somebody, one of you had a question earlier to do with this section. I can't remember who it was, but you want to go ahead and ask that one now?
Yes, I had a question on number 11.
Can you just tell us what it is?
Is the same as that one that you did with different numbers.
Okay, so just go ahead and give me the numbers.
2x plus 3. And then the division, 7x squared minus 3 plus 4x plus 2x, and then the 3 at the top.
So if I got that correct?
Yes.
Okay, so there's no missing terms, but the inside the dividend isn't in descending powers. So we rearrange it, 2x plus 3 outside. On the inside, we'd have 2x cubed plus 7x squared plus 4x minus 3. So again, there's no missing powers that I have to put a 0, but I need those in descending powers of x. X cubed, x squared, x to the first power, no x at all, or x to the 0 power. Okay? So now we'll proceed. Leading term inside divided by leading term outside. 2x cubed divided by 2x is x squared. X squared times the quantity 2x plus 3 is 2x cubed plus 3x squared, 2x cubed plus 3x squared. Subtract that quantity from what's up above. Change it to addition of the opposite. 2x cubed plus negative 2x cubed is no x cubed. 7x squared plus negative 3x squared would be positive 4x squared, and then bring down the next term. You following this okay?
Yes.
All right. So again, leading term inside divided by leading term outside. 4x squared divided by 2x would be 2x, so plus 2x. 2x times 2x plus 3 is 4x squared plus 6x. 4x squared plus 6x. We'll subtract that quantity from what's up above. Change it to addition of the opposite. Add up the columns. 4x squared plus negative 4x squared is 0x squared. 4x plus negative 6x is negative 2x. Bring down the next term, minus 3. Start over, leading term inside divided by leading term outside. Negative 2x divided by 2x is negative 1, or minus 1 up there. Negative 1 times 2x plus 3 is negative 2x minus 3. Negative 2x minus 3. We're going to subtract that quantity from what's up above, but we're going to change it to addition of the opposite, and we get 0 remainder. So our answer is x squared plus 2x minus 1. All right with that?
Yes, thank you.
Yeah. So that didn't, again, it didn't have any missing terms, but we needed to put those terms in descending powers. Just like if I took 417 divided by 12, and I put 12 outside, and I put there, I'll just put 417 and wrote it like that, it wouldn't make sense, would it? If we get the wrong answer. So you've got to have things in their proper place, everything in its proper place. All right, let's see here. How about, let's see, let's go back a ways. So basically still in 5.8, but I've covered everything there is to talk about. So now I just kind of want to do examples from throughout 5.8. Let's say I've got 112 u z to the 4th divided by negative 42 u cubed z to the 8th power. So I just have a single polynomial fraction or a rational expression with a monomial on top and a monomial on the bottom. So I'm going to just reduce it down. Let's see. I believe that 112 divided by 42 is that 3? Let's see. I thought it was. 112 divided by 42. Oh, no, it's not. It's not 3. Well, I could take a 2 out. Let's see. That would give me what? 56 over 21. Does that reduce any further? Can I take anything out of 56 that I can also take out of 21? Is there something that goes into both? Think of your times tables. What times what equals 56? Come on. What times what? 56. 7 times 8. What times what is 21?
7 times 3.
So they both have a 7 in them. So let's divide by 7. We're going to get 8. By 7, we're going to get 3. So we end up with 8 over negative 3. Okay? Going on, u over u cubed would be u to the negative 2 power up on top. Z to the 4th over z to the 8th would be z to the negative 4 power up on top. So now I've got 8 u to the negative 2, z to the negative 4 over negative 3. Okay, that's just getting rid of all the stuff I crossed out. I'm going to move the negative sign either out front or to the numerator. So I'm going to get negative 8 over 3. I'm going to take the u to the negative 2 on top and write it as u squared on the bottom. Z to the negative 4 on top and write it as z to the positive 4th on the bottom. So I end up with negative 8 over 3 u squared z to the 4th. I could also write it like this, negative and then 3u squared z to the 4th. So I could put that negative sign, either attach it to the numerator or put it out in front of the whole fraction. But we don't tend to leave the denominator negative. All right, any questions about this one? Let's say I've got a polynomial, in this case a binomial, divided by a monomial. So here we're going to split up each term in the numerator divided by the term in the denominator. The first fraction I can reduce n over n to 1, so I get 10, and minus 6 over n, I can't do anything with the 6 over n. Okay with that? All right. Let's take a cubed plus a divided by a plus 3. So I've got a polynomial divided by a polynomial. That's where I'm going to use this long division form we've been using. On the outside, I've got a plus 3. On the inside, I've got a cubed plus 0a squared plus a plus 0, because I'm missing my a squared term and my constant term. Okay with that? See where I put in 2 missing powers there? All right.
Yes.
Leading term divided by leading term. A cubed divided by a to the 1st power is a squared. A squared times a plus 3 is a cubed plus 3a squared, a cubed plus 3a squared. To subtract that quantity from what's up above. Change it to addition of the opposite. A cubed plus negative a cubed is 0a cubed. 0a squared plus negative 3a squared is negative 3a squared. Bring down the next term and start over. Leading term inside divided by leading term outside. Negative 3a squared divided by a would be minus or negative 3a. So minus 3a. Negative 3a times a plus 3, negative 3a squared minus 9a. So negative 3a squared minus 9a. I'm going to subtract that quantity from what's up above. Change it to addition of the opposite. Negative 3a squared plus positive 3a squared is no a squared at all. A plus 9a would be 10a plus 0. Okay. So I'm going to take the leading term inside divided by the leading term outside. Let's see, 10a divided by a is 10, so plus 10. 10 times a plus 3 is 10a plus 30, so 10a plus 30. Subtract that quantity from what's up above. Change it to addition of the opposite. Add up each column. 10a plus negative 10a is 0a. 0 plus negative 30 is negative 30. So I've got a squared minus 3a plus 10 plus negative 30 over a plus 3. That's 10. And there's my answer. So that one had a remainder. Any questions on this problem I just went through? Okay. Let's see here. Let's take, this is the other look-alike. So part A says 16a squared minus 16, or 16x squared, excuse me, minus 16x minus 5 divided by 4x, okay? And part B is 16x squared minus 16x minus 5 divided by 4x plus 1. So the numerators are the same, but the denominators are different. In part A, the denominator is a monomial. So we're going to split it up into 3 separate fractions like that. Okay. Then reducing each fraction, 16 over 4 is 4 over 1. X squared over x is x, so I get 4x minus 16 over 4 is 4 over 1. X over x is just 1, so minus 4, and then minus 5 over 4x. So that's my answer to that first division. So again, if we're dividing by a monomial, you separate it into separate fractions and reduce each one. Part B, we have a polynomial divisor. Okay, it's a binomial in the divisor. So here we're going to use this long division form, 4x plus 1. There's no missing powers, and they're both already in descending order, so that's good. Leading term inside divided by leading term outside, we get 4x. 4x times the quantity 4x plus 1, 16x squared plus 4x. Subtract that quantity from what's up above, change it to addition of the opposite. 16x squared plus negative 16x squared is 0x squared. Negative 16x plus negative 4x is negative 20x. Bring down the next term, minus 5. Take the leading term inside divided by the leading term outside. Negative 20x divided by 4x is negative 5 or minus 5. Take that times the divisor, 4x plus 1, negative 20x minus 5, negative 20x minus 5. Subtract that quantity from what's up above. Change it to addition of the opposite, and we get 0 remainder. So, different answers, different problems, different processes. Or is that processes? I don't know. Anyway, so recall dividing by a monomial, you split it up into separate fractions. Dividing by a polynomial, you use the long division form. Your dividend and divisor both need to be in descending powers. And if there's any missing powers, put in a 0 times that variable to that power. Okay. Let's see here. Is there any particular kind of problem from this section you'd like me to look at more, like the one where you have to put in the missing powers or you have to put it in standard form?
Can we do another one where we, I think it was on your slide number 19.
Slide number 19. So we've got a monomial divided by a monomial.
Right.
Okay,
I
you
think
betcha.
I get a little caught up when we have to switch the positives when the
Exponents.
yeah.
Gotcha. You bet. let's take a look at that. Let's see here. Okay. Negative 65 r s squared over 15 r squared s to the 5th power. Okay, I'm going to break this part apart a little bit more than I have been. We're going to focus on this part, and then this part, and then this part. Okay, so negative 65 divided by 15. 5 goes into both. Okay, so let's see. Negative 65 divided by 5, let's see, that would be what? Negative 13 over 3. Is that right?
Yes.
Okay, so negative 13 over 3. Now let's take r over r squared. Okay, that's basically r to the 1 power over r squared, right?
Yes.
So that would be r to the 1 minus 2, top exponent minus bottom exponent, which would be r to the negative 1. Okay,
Yes.
which would be 1 over r to the 1. So this is going to be times 1 over r to the 1 power. So far, so good?
Yep.
And then s squared divided by s to the 5th power. That would be s to the 2 minus 5, top exponent minus bottom exponent power, which would be s to the negative 3 power, which would be 1 over s to the positive 3 power. Are we okay with that?
Yes. And the reason why we're switching it on the, since you did s, is it the 2nd power minus the 5th power, you get a negative 3.
Yes.
So on the bottom, you said it would be a 1 over s3.
Right.
Why did we flip that? Was it because we can't have a negative on the denominator?
Okay, right here, that's still in the numerator.
Correct?
So I write the reciprocal of the base and apply a sign change to the exponent.
Okay.
So basically, a to the negative n equals 1 over a to the positive n. So s to the negative 3 is 1 over s to the positive 3. R to the negative 1 is 1 over r to the positive 1. Okay, now let's take all of this and put it together. We've got negative 13 all over 3 r s cubed. And I'm going to drop that exponent of a 1 on the r because it isn't necessary, it's implied. All right with that?
Yes.
Do you want another one of those, or are you okay?
No, I'm okay. Thank you.
All right, anybody else? Anything from this section before we call it quits for the day? All righty, well, I'll be back at 1:15 with an office hour. So tonight, your homework is to finish up section 5.8 and the chapter review. Tomorrow we'll review. Like I said, I won't be available this weekend till late Sunday night. Monday, we'll have a test. You can take it anytime. Basically, you can take it anytime up until Monday night at 11:59. But once you open it up, time starts. And there'll be no Zoom class meeting on Monday. All righty. I will see you all tomorrow. Let me stop the recording.